Hello everyone and welcome to this week's engineer interview, this week with Ajaso. Now my name's Scott and I work at Primary Engineer. Now before we start I just wanted to say a massive thank you for signing up to this year's competition. It's our 10th birthday this year, so thank you for celebrating it with us. Now for those of you who don't know, this is the Leaders Award competition from Primary Engineer. And we asked the question, if you were an engineer, what would you do? Pupils from the ages of 3 to 19 anywhere in the UK can join, and every single person who takes part receives a graded certificate from a real-life engineer, just like the ones we interview. We then host public exhibitions of all of these engineering ideas, so we can celebrate everybody who took part. Now, we can't wait to see all of your creative ideas. You're going to get some added inspiration today from our special guest speaker. Now, as part of these interviews and the whole series, we're going to be speaking with engineers who work on loads of different projects, all of them showing the wonderful, interesting and exciting things that happen when you work in engineering. Although these interviews are hosted live, we do upload the replays to our YouTube channel so you can watch them at your leisure. Now, our special guest is going to start with a 10-minute presentation all about the exciting world of engineering and Rockwell automation, and then we're going to open up to questions from the audience. If you would like to ask a question, please use the chat function in Teams to type it in there. We unfortunately can't receive audio from the audience, so if you do have a question, just type it in. But for now, I'm going to hand over to our special guest, Jessa.
So my name is Jessa, and I'm an application engineer. I work for a company called Rockwell Automation. So just a few slides there to show sort of what we do. Rockwell Automation is an industrial automation company that provides industrial solutions, automation solutions for lots of industries across the world. So we're talking hardware, software, drives, and all things like this. The company was founded in about 1893 when we had these two brothers started it off with making the first motor control, and from then it's grown, and now we're in over 100 plus countries, over 24,000 employees, and yeah, we've been serving customers for 118 years. So the sub industry, where basically Rockwell systems are found in a lot of industries across the globe. So I've put them all up there, from aerospace to entertainment, food and beverage, household and personal care. So at the bottom here, you've got like an aeroplane, really. So we provide systems, software systems for aeroplanes. You find our systems also in oil and gas, on our oil and gas platforms, in oil and gas industries, and also in electronics. So it's really quite a vast amount of industries are served by Rockwell Automation. So a bit about me. My job title is application engineer, but I'm actually a chemical engineer, also called process engineers. I chose engineering when I was in my A levels. My alternative was to do medicine, but I discovered I don't actually like the sight of blood. And my favorite subject is chemistry. I still quite like chemistry and also like mathematics. My hobbies, I like to read, I volunteer. I like to cook, I like to run, I travel. I like to travel and just basically just explore castles and stuff like that. I also like to eat, so it's an hobby. How did I get to engineering? So, like I said, in secondary school, I really liked chemistry, and at first I thought I was going to do medicine. So I set A levels in chemistry, biology, and physics, and decided I didn't like biology after all. And so I dropped biology and went into to do mathematics. So I did chemistry, mathematics, and physics A levels, and then went on to do a sandwich degree course. And then after that, started working in my field. So what do? I an application engineer that I design applications to optimize and control engineering processes using mathematical models. I thought, if I talk about process engineering, what does that actually mean? So I went to Wikipedia to look it up for you, so you know what process engineering is all about. And process engineering is really the understanding and application of the fundamental principles and laws of nature that allows us to transform raw materials into products that are useful to society. So process engineering is everywhere, really. Like, you know, your breakfast cereal, it's from corn. It's been processed to make cornflakes or Rice Krispies or whatever else it is you eat for breakfast. Orange juice, like, you know, the canned stuff or the bottle stuff, Tropicana, again, that's the process from fresh oranges. I mean, it's not just that, it's a whole vast of things. Anything you can think about that we use in the home started off with raw materials that are processed and then become the final product that you see. So that's what process engineering is all about. And we produce, I do data analysis. So when I start a project, when we do call projects for the projects, the work that we do, and what we do is we using data, we create a model of a system, and a model of a system is just an information representation of a system, basically using mathematical models. I use software to do that. It's not as complex as it sounds. What do I like about my job? So the thing about my job is I do a lot of variety of stuff. So I'm, like, for instance, at the moment, I'm working on two projects, or maybe two or three projects. One is in Brazil, and another one is, I just finished one in Ireland, and these are different processes. I mean, I work a lot with dairy processes, and also I've done dairy, I've done cements, and so just different processes I work with. I also do a lot of before COVID. I used to do a lot of traveling with the job, traveling to different sites across the world. I had a project in Canada once. So yes, I've done a lot of travel with my work. Every day is different. Today, for instance, I'm doing this, but the work I'm going to take on afterwards is totally different from what I did yesterday. So every day is different. And I really enjoy working with my work colleagues as well. They're a nice bunch of people. So typical day, there isn't one. I don't have a typical day. So this is an example that I've put here of a couple of the projects I've worked on. So these are actually two projects. So we start off with raw potatoes. And so with the raw potatoes, you can process them one way, which is, you know, making a French fry. So you go through this process, and this is just one of the processes through it is called, it's actually a sorter. So when the potatoes are brought in, they're cut up, you know, into the size of the French fries or chips or whatever, and then they go through a sorter, and they go through another process and another process, and eventually we end up with frozen chips, which, you know, we then sell in supermarkets and, you know, and other places as well. Another use of potatoes is to make potato starch. Again, a lot of energy to kind of like, I call it an explosion of the potatoes, because they're subjected to high heat, and then the starch is extracted, and through various number of processes, we end up with a starch powder here. And this starch is used as a base for medicine capsules, you know, paracetamols, places, things like that. And also as a binder in glossy paper, which is then used to make magazines. So you can see from the potato, where we've got French fries, which we eat, and also we've got magazines that we read, and you know, pharmaceutical capsules, which we, you know, take as medicine for our bodies. Another thing that I've worked on is dairy, again, from cows. We get the milk and we process it, and through a set of evaporators, it's dried and it becomes a powder. And some of this powder is then used to make baby food, or just skim milk powder to be used in coffee and things like that. Another process is chocolate, manufacturing of chocolate. There we start off again with the cocoa pods, the beans, which is grounded into cocoa nibs, and again it's a process. And the grinded is grinded and then blended. Milk and sugar is added, and you end up with Cadbury's buttons, as an example, molded chocolate. The last bit, the last process I'll talk about is cement. Again, the raw material here is from a quarry, so rocks and stuff from a quarry processed again. A lot of heat is added and to break down the materials and everything like that. We end up with cement, which is then used to build homes. Yeah. So just to talk about what we do, how we add value to processes by using data. So we improve efficiency in how all the processes I talked about. My job is to improve the efficiency of these processes by using the data that we collect about the process we basically set things like temperatures and pressures and operating parameters to make the process better, because for each product that you produce, there's a set of conditions that you need to happen for everything to be optimum. And so that's what I do with data. Another thing we look at when we're using with the use of our data is we reduce energy cost, increase productivity. I've got reduce energy cost twice in my slides, reduce downtime, reduce process variability, and improve product consistency. Yeah. So just I've gone through that really quickly, I know, but I think I was meant to present for 10 minutes, so we have time for questions. So the challenge really is all the processes really that I've worked on, a lot of energy is involved in it. So you're looking at either heating up air temperature to dry powder, or you're looking at burning a sort of form of fuel. Like in the case of the cement process, you're looking at burning fuel to kind of like get to burn stones, basically to burn rocks, to get to to break it down. And we're talking of temperatures of 1,300 degrees Celsius, which is quite high. So you need to supply that kind of energy to burn down these rocks. So they eventually end up with like a powder, really. So a lot of the challenges that we have in industries, especially now, is how do you source energy? And because a lot of processes are energy intensive. So that is the challenge, is that we're looking more and more for better sources of energy, and we're looking also at reducing energy costs, so making our processes more efficient, so we use less energy. And that's really the challenge. How do we make our processes more efficient, use less energy, and meet the demand? Because obviously there's always demand. You go to the shops and you expect to find products like French fries or anything else I've talked about, beverages, Pampers, things like this. You expect to find all this in the shops. And so this is all in the background. It's all making your process more efficient so you can meet the demand. The other challenge I would say is for the kids is look around you, what raw materials you have around you, and what process can you come up with the raw materials that you have around you. I think that would be quite interesting. So yeah, so that's my presentation.
Because I have a question for you, Theo. I'm sitting at my kitchen table. It's made of wood. I've got a computer in front of me. I've got a fruit bowl with bananas in it. How much of this is only possible because of engineering, like the engineering you do at Rockwell?
So you've got your kitchen table.
Yeah, kitchen table. I'm sitting in front of a computer. I've got a fruit bowl. I mean, I'm just thinking now that if potatoes are used to make magazine covers, then there's probably so much more in the world I don't even know about.
Yeah. So with the bananas, I guess you could use that in breakfast cereal.
Yeah.
It is a breakfast cereal. I was gonna say, you can buy ready-made banana bread from Sainsbury's, so one of the supermarkets. So yeah, you can use the bananas as well to make this. And you can also have dried banana chips, which you can use for as a snack. The other thing is you can actually use, which we probably wouldn't, but you can use bananas as a form of biodiesel, really, because we talked about fuel, right? And so you can sort of like ferment the bananas and get methane gas, which you can then use to drive a turbine or something.
Wow, that is pretty good, actually. Yeah. Oh, I like that one. I'm gonna keep a note of that one.
Yeah. And so what was the other thing? You got a cup of coffee?
Yeah.
Yeah, so coffee beans actually. So coffee grows on trees, doesn't it? So you've got your raw material coffee. I guess they're pods, coffee pods, and you take that from the farms and everything like that, and you basically have a process, because you have to process it. You have to grind that and into like a powder form. But first you mix. I think you grind it. I'm not too sure about the coffee process. I haven't really researched it, but you must grind it somehow, and it becomes like a solution, which then has to be dried, so freeze dried. So you see, like where you got your instant coffee, they're like little granules. Yeah, that's a drying process, which is a similar process that we used to make the milk powder as well. So again, yeah, so from raw coffee, the coffee beans, as you get them farmed in the farms, and then back to the process, and then you freeze dry it, and then you get your instant coffee granules. Yes.
So engineering sort of touches every aspect of life before it
Yes,
even
it
gets to us.
does. Yes, yes. And I mean, even I don't know what material your table is made of. If it's made of some kind of wood, it would have been treated with a chemical or something, which again would have been produced in a process in a chemical industry, right? So these chemicals would have been produced from again raw materials that you would have naturally occurring, and then you end up with this material that's then used to treat the table, treat the wood. Because if you just take wood from the forest as it is and make a table out of it, I think you might find you have all kinds of termites and bugs in it that might attack it, and then you end up with no table, right? So yeah.
Not ideal for the house. Well, if anybody out there does have any questions, make sure you type them in, but we've had some sent in to us. One of them, Theo, is, what do you love about your job?
I like the variety of it. I like the fact that I've been able to work on different processes. So like I explained through the slides, I've done chocolate. I've worked in a chocolate making manufacturing facility. The potato starch bit, I've worked in that as well, and that involved travel to another country. And one of the things I like when I go, we call it going to site, when I go to the industrial places where all the processing happens, is just the sheer size of the places. You've got huge machinery, you've got robotic arms, you've got pipes, you've got so many things, and to me, just the sheer scale of being there, like machines, you see, I really like machines, and they shine. They have a shine to them. So just visiting places like this, I like that. I like I said, the variety, and yeah, and the fact that I've been able to travel quite a bit with my job. I like that about my job. Yeah.
That is pretty cool, getting to go and see lots of big machinery all over the world.
Yes.
So we've got a couple of questions coming in, some from Miss Parker, and one of the questions is, what qualifications do you need to do your job?
So I started off with a degree in chemical engineering, but I've got colleagues who got degrees in other types of engineering. So from secondary school, I chose science. So I chose science subjects like biology, physics, maths, chemistry. And then I did my A levels in the second time around in physics, maths, and chemistry, and then went on to do a degree in chemical engineering. Yeah.
So there's quite a lot of questions about what you've been able to do since then and the projects you've worked on. So we've got one question, a couple of questions from Miss Parker, which is, what is your favourite project you've worked on, and has anything ever exploded when you've worked on it?
God, I can't say I have a favorite. It's hard to choose, because sometimes I think that was a favorite and another one comes up. Sometimes, yeah, my favorite one is hard to choose. Yeah, I can't really say I have a favorite based on that. I might say a favorite maybe based on location. So I worked on a project in Norway, and the plant site was right by the water, and it was really, really beautiful. And
That
even
sounds
the town
amazing.
itself was really beautiful. So I really liked that project. Yeah, so that based on location, I'll say that was one of my favorite ones. But like I said, it's hard to choose. The I worked on a French fries project, and that was also quite good, because you got to sample stuff.
Ah, I knew it. I knew it.
So yeah, and what was the other bit to the question?
Has anything ever exploded when you've been working on
Um,
it?
no, no, no,
Probably a good
that
thing.
wasn't me. That was someone else. No, nothing really has. The stuff that we do with software and everything like that, the most we will get is maybe a process overrun, meaning that we're filling up tanks and things like that. So you might get too much liquid went into the tank, and so the tank overflowed. I've never worked on a process where we're looking at explosions. Though the cement one could have come close because they work at such high temperatures, but of course
Yeah.
it's all safeguarded, so the chances of that happening very slim.
Well,
Yeah.
that's a good thing, I think.
Yes.
We've got some questions from Strathier Primary. Mr. Martin asks, what advice would you give to someone who wants to be an engineer?
I'll say go for it. Just so engineering is very interesting, and I think there's also this perception that it's quite difficult to do. But one of the things that I find is practice, practice, practice. So when it comes to do with getting your qualifications, like maybe doing your GCSEs or doing A levels even, you can what I did was you practice lots of exam questions, a lot of studying. You have to be dedicated, yeah. The other thing to consider is that you don't have to have a degree to become an engineer. You can actually go through an apprenticeship and become an engineer that way as well. So that's another thing to note. Yeah.
So go for it. That's the
Go
advice.
for
Go
it.
for it. Yeah.
Yes. It's an interesting profession. There's so much to it. Yeah. There's a lot to
And
it.
there's so much, like you'd said, there's so much to engineering that you don't see. And that's another question Mr. Martin in the Strathier Primary had actually, which is, what's your favourite invention? Because that was probably invented by an engineer. It's a bit of a
Yeah.
big one.
Yeah, it's a big one because it's not something I've thought about. Favorite invention. I once went through and I saw a list of things that chemical engineers had actually invented, which I thought was very interesting, but I can't think of one right now.
But it's just yeah, I think it's that there's so much out there that engineers have helped create, which I think is so special, and it's something I didn't know about until interviewing people like you to sort of
Yes.
like all the different aspects of it.
Well, I'll say maybe the computer is my
It's quite
favorite. Yeah.
helpful.
Yeah, because I use it a lot for my job, and I sometimes I might not even have a phone, but I have a computer, a laptop, right? So yeah, so I'll say that's my favorite invention.
So I've got a question from something you said earlier. Now you said that you love to cook. So
Yes.
does being an engineer help with cooking?
Um, No, I don't think so.
No.
Well, maybe it does because I like using recipes, and you have to be very precise with measurements and stuff. I think I'm one of the few people that I know that likes to cook, that, well, in my circle of friends anyway, that uses recipes a lot. So, you have to be very precise with measurements. And so maybe being an engineer is why, because when I see a recipe, I really go by the measurements. Oh, 100 grams of flour. Okay. 200 grams of this. Yeah. Okay. And I measure it exactly as it says. And maybe because I deal with numbers a lot, so everything has to be quite precise. And yeah, that probably helps my cooking. I find people are surprised that I like to cook being an engineer. I don't know why.
I think we've got another question here actually, and this one was sent in to us, and it's is there a person or a thing you did when you were younger that inspired you to be an engineer now?
um, I think what it was when I first started learning how to read, someone around me had a book on astronomy about the stars and going to the moon and stuff like that. So that was where my interest was first sparked with going into space. And so I explored that more. And yeah, so that actually sparked an interest in science, just reading about space. Yes.
Brilliant. We've got another one here that asks, what was the first project you worked on, and what are you working on just now?
Oh, the first project I worked on. Sheesh. It was probably, yeah, I don't remember the very first one, but I think I worked on an ethylene project, which was ethylene is used as a base material and for plastics and stuff like that. So it's one of the materials that is used for plastics. And what I'm working on now, I'm working on a dairy project, which is you know, powder manufacturing of powder for baby food. Yeah.
All right.
Yeah.
So we've got another question here, and it's, do you get to work with a big team, or do you do a lot of work on your own?
So it depends on how large the project is. It varies. The current project I'm working on, there's two of us on the project. I've worked on projects where there's been like lots of engineers, maybe about 5 or 10. And then when we do like the large automation projects, you'd have different disciplines coming in because we've got the hardware side of things, software side of things. So it can be quite a large group. So I think I've worked on a project where there might have been, I don't know, I was going to say 30 people because everyone was doing different things. So yeah, so it depends on you know what type of project it is. But yeah, projects can get quite large and they can be quite small as well. And sometimes a couple of times I've worked on a project just by myself. So yeah.
So as you get a great variety, and you must work with some really interesting people as well.
Yes, I do. I don't want to talk about them.
Oh, brilliant. So we do have time for a couple more questions. So if you're sitting on one, please send them in. But we've got a question here, and that's, can you sum up engineering in 3 words?
Oh, gee. Exciting, fun, knowledgeable. Is that a
I like
word?
that. Anything exciting and fun, and I'm up for that. That sounds quite
Yeah.
good.
Yeah.
So I think we've got a couple more questions in. Um, and we've got one. What is the most interesting stage of the design process?
So when we get a project, typically what happens is we go and speak to the client and then they tell us about what their issues are, so why they want us to come in and optimize their process, and they talk about the challenges they face. And so that's the most interesting part, where you're hearing about the different things that the different things around the process. And because even though you have similar processes, no, even in the same plant, no two processes the same. Even though they're similar, they're actually not the same. They have different challenges. So like finding out about the challenges and seeing how you can help them, that's the interesting part, the very beginning. Yeah, for me, that's the interesting part.
Because everyone will have different needs, won't they? Everyone will need something different from a process and say, I've got this material and I need to create this. How do we do that?
Yes.
So I think we've got time for one more question, and Miss Parker has the question. So have you worked on any space projects or with companies that do stuff in space? That's, you inspired your love of science from a young age in space. So have you managed to do anything with it?
No, I haven't worked on any space projects, but what I will say is the equations that we use to build to optimize the process is also used in space theory. So yeah.
Oh, really?
Yeah. So it's nonlinear dynamics and a few other things, mathematical equations that's used to determine the flight path of a rocket, the trajectory of a rocket. So yeah, so similar things. So that bit was very interesting when I was doing my degree, to find out that okay, these equations that we use, but they're going to be used for this, is also used in space theory. So yeah.
That's quite cool. And I think we've got one last question here, and that question is there a project you really want to work on and haven't had the chance yet?
No, I won't. No, not really.
Well, that's good because you've had so many fun projects you've worked on. You couldn't even pick a favourite, and that one in Norway sounds like more like a holiday than work to me.
Yeah.
Perfect. Well, Theo, I want to say thank you very much, and a special thank you to everyone else out there for joining us. Now you've heard about what it's like being a process engineer, it's your turn to come up with your own engineering ideas. Remember and send them to us once you're finished so we can get our certificates sent out to you, and then we'll hopefully see you all in person at our public exhibitions at the end of the school year. Now, don't forget, this interview will be uploaded to YouTube in full, so you can share it with other teachers, or if you want to rewatch it in full, you can catch that next week. And additionally, did you know that we've got a podcast series? We're currently coming towards the end of season 2 of the podcast, with episodes being released every Friday. So be sure to check out our website, where we interview loads of exciting people, just like we've interviewed an exciting person today. But for now, I just want to thank you all again for joining us, and a massive thank you to Theo for inspiring all the engineers in the making out there. But for now, I'm going to leave it with you to answer the question, if you were an engineer, what would you do? Thank you very much, and thank you, Theo.
Thanks. Bye-bye.
Thank you, everyone.